Hello and welcome to lesson 4.3, glide reflections. Today you're going to be able to identify isometries, identify glide reflections in certain images, and the last thing is something that may be new to a lot of you, or actually all of you, classify freeze patterns. So that's going to be something special that we're going to learn. And they're going to make you think, but they should be fun. So first we're going to start with our vocabulary. An isometry is a transformation that preserves size and shape. So if I look, for example, if I take this, if I create a triangle, and I reflect it over a line. That's what I would end up with. So a reflection, the question is it an isometry? And the answer will be yes, it is, because it preserves the size and shape. The triangles are still the exact same size, and they're still both triangles, so it maintains shape. So one example of an isometry is a reflection. Another one we learned is a rotation. When we rotate an object, it still maintains the same size and shape. When we translate, it's also an isometry. And the last one we're going to learn today is a glide reflection, and that is an example of an isometry. The next definition in your book in section 4.3 will be a rigid transformation. A rigid transformation is the same as saying an isometry. It preserves the size and shape of an object. So if you look at those two cubes, they've just been translated. They still have the same size, the same shape. And a non-rigid would be something that doesn't maintain size or shape. So it changes size or shape. All right. So if you look at these two cubes, it's gotten bigger. So that would be an example of a non-rigid transformation because the size has changed. And we know the definition of congruent from our last chapter. Two figures are congruent if there's an isometry that maps the pre-image onto the image. So if we go back to this triangle example, if I were to perform this transformation of the reflection, it would match up perfectly with this other triangle. So those two figures are, are congruent. Wrong way. So we can say these two match up perfectly. So those two figures are congruent. The most important definition of the day is called a glide reflection. And remember yesterday we learned a rotation and a translation. They were a composition of two reflections. Now a glide reflection is going to be a composition of three reflections. All right, and probably something to add to your book would be that it's also the same thing as doing a reflection and a translation, because remember a translation is the composition of two reflections. So in total, if I do one reflection and then a translation, which is two reflections, I'm going to get a total of three. So what you're going to look for when you do a glide reflection is you're going to say, well, first I have to reflect the image, and then I have to translate it. So if I look at this foot, I'm going to copy this foot and I'm going to reflect it over that horizontal line. So that's what I ended up with. So there's my reflection part of the glide reflection. And the second part is I have to translate this over in order for it to match up with my image. So I start with this foot as the pre-image. I have to reflect it and then translate it to get it matched up with the image. So a glide reflection, again, is a composition of reflection and then translation. So all of these feet are an example of a glide reflection. Okay. The last thing we're going to talk about is freeze patterns. A freeze pattern can be categorized into 7 different classifications, and those letters down here, the classifications are right down here. And over here is the final one. So if I look at this, this means it just has translational symmetry. That means I can just take the object and move it and it'll match up with the next image. So this one can be rotated and matched up. This one has translational and vertical line symmetry, glide reflectional, horizontal and glide reflectional, and you get the idea. These letters up here all signify what they are. This is in your book, so you don't need to write it down. So I think the best way to learn these is just to start off with an example and just go down the list and say, does it have this? Does it have that? So if I start with this one, my first step, does it have translational symmetry? Most of them do, otherwise it won't be classified as a freeze pattern, because if you notice, all of the classifications have a T in them. So if we look at this, if I translate the first one over and I keep going, it matches up with the next one. So yes, it has translational symmetry. Okay, let's check rotational symmetry. In rotational symmetry, you can either rotate the whole object and see if any time before you get to 360 does it match up. So most likely 180. Well, I rotated 180. It does not match up with my original, so this one does not have rotational. Sometimes you'll be able to rotate it within and see if it matches up, and that does not match up to any of these. So it does not have rotational symmetry, 180-degree rotational symmetry. I don't think anyone would argue that I can draw a vertical line in here and get it to be a line of reflection. Glide reflectional. In a freeze pattern, we're only going to be reflecting horizontally for glide reflectional. So if I reflect that over and then translate it, it does not reappear to be any of these images. So it does not have glide reflectional. Well, once you rule out rotational, vertical line, and glide reflectional, the rest of them all contain some form of that. So we can cross out all of them except for translational symmetry. Let's look at another example that may be a little more interesting. This one, first check does it have translational, and eventually I'll get this to match up here. Or you could even take the chunk of these two and translate it and it would match up. So it has translational. Right? Does it have rotational? And let's check. We can either rotate the whole object. And if I rotate this 180 degrees, it looks similar, but these little W looking things are going the wrong direction. So it doesn't have rotational. I can cross that one off. Can I draw a vertical line in here and get it to match up? I don't see it. Right, last, let's check glide reflectional. So I'm going to flip this horizontally, and then if I translate it, yep, it matches up. So it has glide reflectional. And I don't think that I can draw a horizontal line in, so it does not have horizontal line symmetry. And again, once we've ruled out rotational, vertical line, and horizontal line, these two no longer become an option. So my answer would be this one is translational symmetry and glide reflectional symmetry. And let's do one more example. Let's look at this one. So if I look at this one, I'm going to start by saying, does it have translation? I want you guys to pause the video and see if you can figure out which one this would be categorized as. All right, I hope you've decided on your classification. It does have translational symmetry. You can see that as I drag this, translate this across, it's going to match up. Let's check rotational. I hope you said that it has a rotational, because if I rotate this around, it matches exactly up with my previous image. Vertical line symmetry, I could draw a line either dividing the object in half, or I could divide the whole image in half and it would still have vertical line symmetry. Glide reflectional symmetry, I hope you said it has glide reflectional symmetry. If I flip this and then translate it, it's itself, so it does have glide reflectional. Horizontal line would look like this. Oops, a little off. Let's just do this. Horizontal line would be right there. Okay, so far it has translational, rotational, vertical line, glide reflectional, and horizontal. I have checked all of them, so that means that it has all of them. So my answer would have been G. Hope you figured that one out. It's a very interesting patterns to look at. If you have any more questions, rewind the video, see if you can figure out other examples. There are some examples like this you can try, or other examples like this you can try. So if you want to try those, pause the video, check them out, and see if you can get the right answer. Have a wonderful day.